Hai, Assalamualaikum to panels, Dr. Hanif bin Muhammad Ramli and Dr. Marziah binti Cik Murad. I am Aainun Mardhiah binti Jaafar will present the final year project FYP1 proposal. The title of the study is Investigation on Resistance Spot Welding of Aluminium Alloy 5000 series using Numerical Computation. I will start the presentation with the table of content that have in this presentation, which is the project summary, introduction and background, methodology of study, expected result, and references. The figure shows the project Gantt chart of the FYP1 from the first week until the last week of lecture, which is week 14. All the planning are followed as set on the Gantt chart. The aim of the project is to study the behavior development of aluminium alloy resistance spot welding. However, aluminium alloy consists of various series up to 8000 series. Aluminium-based alloy are widely used in the vehicle industry due to their low density, high corrosion resistance, and recyclability. Hence, the study will be focused on aluminium alloy 5000 series, which is an aluminium mixed with magnesium. The purpose of the study is to identify the cracking mechanism and mechanical properties of the material based on specified parameter. The observation of the study will be determined by using a MSc MART or MENTAT 2020 software regarding nugget development and tensile. It is important to specify welding parameter including electrode force, diameter of the electrode, squeeze time, weld time, and holding time, and current welding. All the parameters are determined regarding the specification of material to be welded. Resistance spot welding is a resistant welding technique that uses the heat generated by the resistance to the flow of electric current through electrode that concentrate current and pressure at the weld location to heat the work components. The heat generated is used to melt and solidify a nugget at the joints faying surfaces. Resistance spot welding is widely used in aerospace, electronics, especially the automotive industry, due to its high productivity, flexibility, and compatibility. The use of light material, which is metal alloy, is significant for minimizing vehicle weight and, as a result, emission and fossil fuel usage. Aluminium as a resistant welding material, on the other hand, has a tendency to alloy with copper electrodes, causing the electrodes to wear out quickly. In addition, aluminium alloy are characterized by high thermal conductivity and low resistivity, which require very high welding currents. Therefore, cracking is one of the most common difficulties when welding aluminium alloy. Toyota observed nugget solidification failure or liquidation cracking in the heat-affected zone in one of the 5000 series alloy with a magnesium content of more than 5 weightage percentage. Typically, the resistance spot welding process is placing two or more overlapping metal sheets between two water-cooled electrodes and then applying pressure to the electrodes to clamp the workpiece together and make close contact. After that, electrical current is passed through the two electrodes to the workpiece for a set period of time. Heat is generated as a result of the sheet's resistance to the flow of a constrained electrical current, and a molten nugget forms at the faying interface. Heat is generated preferentially at the joining or faying surfaces of the piece to be connected when an electrical current travels through the metal. When the welding temperature is reached, the electrode force welds the part in spot at their contact locations between the electrodes. In aluminium alloy 5000 series consists of classes of nominal composition percentage weight. Each class has its own application. This study is focusing on aluminium alloy AA5754. The AA5754 alloy has good formability, good static, impact and fatigue strength, and great resistance to pitting and intercrystalline corrosion, as well as a stable microstructure. Hence, table below shows AA5754 properties that has been extracted from journals and research article. According to this study, The structure of aluminum alloy is analyzed by a 3D simulation called MEC601 Method 2016 or 2021 software. The selection of the software is based on its specialty on creating a 3D spot welding modeling by combination of two metal plates, two electrodes, and current applied. Moreover, after completing the model of the simulation, materials, parameters, and boundaries conditions are included in the simulation. The objective of the study are to analyze the development of nugget in resistance spot welding using simulation and to evaluate the strength of the spot welded specimen by tensile strength using simulation. This study is focusing to observe the development of nugget to the resistance spot welding process and tensile test to the specimen. Therefore, it is required to obtain the parameter of specimen and electrode respective to the temperature. Both characteristics of specimen and electrode are important to be determined. Therefore, the observation of the study is conducted by finite element method by using a MEC601 Method 2016 or 2021 and simultaneous welding software. However, there are some limitations to complete the study, which is the limitation of study that was conducted by FEM regarding nugget development, and limitation of data found of parameter against temperature regarding selected material. The flowchart illustrates the steps involved in completing the study successfully. The flowchart purpose is to ensure that the study flows as a set of steps to be complete. Gather information. The first approach that applied in this study is to gather the information from the research on the previous journal and research paper. Based on the found journal and article, all the important information related to the aluminum alloy resistance spot welding has been extracted and recorded. Next, construct literature of the finding. The selected research and journal will be examined in further depth. To serve as an appropriate reference in this project, the study's foundation will be compared and filtered. Mendeley software is used to organize and manage research paper. This is very useful for writing literature review. The software highlights and analyzes the equation and formula in the research publication to ensure they are relevant. Selection of material. The use of aluminum alloy as structural material is one appealing area, and its use is commonly depend on the shaping and connecting of aluminum pieces. The non-heat treatable aluminum magnesium alloy 5000 series in sheet form are among the most promising aluminum material, with AA5754 being specifically designed for the automotive industry. Material AA5754 was chosen in this study because of its characteristic that has good formability, good static, and high resistance. Parameter studies. The parameter of the material aluminum alloy 5000 series is studied by reviewing from the previous journal and research paper. The parameter of the studies regarding the material consists of temperature, plasticity, thermal conductivity and resistivity, electric conductivity and resistivity, Young modulus, density, specific heat, electric contact conductivity, and thermal contact conductivity. Also, the value obtained are then compared to ensure the parameter study are approximately accurate. 3D simulation. The mathematical modeling of aluminum alloy 5000 series, which is AA5754, is analyzed by MEC601 2016 or 2021 software. This software was chosen because of its ability to construct a 3D spot welding model using a combination of two metal plates, two electrodes, and current. The simulation includes the material, chemical composition, parameter, and boundaries condition. The material properties can be extracted and imported from MEC601 method software as well. During construct a mathematical modeling of resistance spot welding, it is important to ensure all the input of the parameter value is correct. This is because a mistake will affect the simulation and present incorrect simulation. However, if the analysis conducted not shown the expected result or wrong result, it is compulsory to restudy from the parameter studies until 3D simulation. The expected result of the study is the study should provide an overview of the growth of the weld nugget development in resistance spot welding using MEC601 software 2016 or 2021, as well as the tensile test observation to the selected material, which is aluminum alloy AA5754. The simulation may include both up and down electrode and 2 plate of aluminum alloy 5000 series sheet. Also, the weld time need to be considered to ensure the objective of the study can be achieved. I end my presentation with the references used in the journey of FYP1. Number 1 is failure mode transition of triple thin sheet aluminum alloy resistance spot welding under tensile shear loads. Number 2 is a study of the heat transfer mechanism in resistance spot welding of aluminum alloy AA5182 and AA6014. Number 3 is finite element analysis of resistance spot welding in aluminium. Number 4, cracking in spot welding aluminum alloy. Number 5, a correlation study of mechanical strength of resistance spot welding of AA5754 aluminum alloy. Number 6, a review on resistance spot welding of aluminum alloy volume 90. Number 7, review of resistance spot welding of steel sheets. Part 1, modeling and control of weld nugget formation. Number 8, computer simulation of resistance spot welding. Number 9, development in characterization of resistance spot welding of aluminium. And the last one is thermal contact conductance effect in modeling of resistance spot welding process of aluminium alloy. That's all from my presentation. Assalamualaikum and have a good day. Thank you.